Debmarshal is a project that was written last summer by an intern, Chuan Kai Lin. I was supervising him, and it was intended to be released as an open source project. It has been now. It's out on code.google.com, and it is designed to solve a problem that we had, which is to produce Linux distributions for service owners. There's a basic conflict that service owners have. While they are putting together their service and getting ready to deploy it, they want changes made to the distributions. They want their fixes put in, they want their software added, they want all these things. And as soon as they deploy, they want no more changes instantly. And that's basically two different distributions, one of them that's changing and one that's not. And since service owners are continually rolling out new services, we continually need to have these frozen and developing distributions. The software that exists to release distributions is fairly cumbersome. Debian, for instance, releases every few years. Ubuntu drives the cycle faster and releases every 6 months. We wanted to be able to release at least every 6 months and probably every couple of months because there are new services all the time here. This is a public project, but if you have questions about confidential information, go ahead and ask me afterwards. So some of the features that we added to Debmarshal to support this, the top thing was simply to maintain a Debian or Ubuntu software repository that was a mirror of what was going on in the upstream and be able to stage it out across the enterprise. The other thing we wanted to do was to be able to add packages to it, so process an incoming queue and build up another release of packages that were added onto that, and stage them out. We don't want to make a change and instantly roll it out to every machine in Google and find out that we broke libc6 again. We also wanted to be able to preserve all of the snapshots that we had taken of this release, continually being able to roll back to test whether something was working, and have multiple stages where all this was going on. And we wanted to automate consistency checks. Yes? Preserving both of them. Debmarshal manages both the source and the binaries. And so we just stick all of them on there. Disk is cheap. It's much cheaper to save everything than wish you had saved one thing. And we wanted to automate distribution-wide consistency checks. Things like, does every binary that's in a distribution have a library that it needs in that distribution? One of the common problems that Debian has is that something will get uploaded that's linked against unstable, but it's uploaded and propagated through to stable without having everything make it through. There's some complicated logic that goes on in making sure that happens, and every once in a while it falls over. For Ubuntu, it falls over a bit more often. And what we mean by a distribution is just a list of packages. The way a Debian repository is structured is that you have lists of packages for all of the different releases that you might have. They're all referencing one pool of packages. So if you upload version 6 of a particular release, even though you have multiple distributions, version 6 of that package is only in the pool once. All of them reference it through the packages lists. They have indexes. In the packages lists themselves have checksums of the binaries and the sources that are in them. There's a release file that lists all of the different indexes and their checksums, and that release file is signed with a GPG key, ensuring that you really are getting what was published. Here's a look of what a typical Debian archive looks like. Yes?
Why would it use a checksum to track a package rather than some version number? Like if the metadata in the package were to change.
The checksum is there to ensure that you're really getting what you were supposed to get. The versions and version numbers and file names are also in there as well.
Well, they get checksum too.
Yeah.
But I guess you're saying it's not sufficient to know that you have version 4.4.4.2.p or whatever. You need to actually know. You're trying to verify, I guess, that you have the exact same package archive.
Yeah, you're not just having a package that claims to be version 4.2. You're having the version 4.2 that Debian published.
Okay. Or that you published.
Or that you published if you're running your local pool. So for a Debian release, you have the dis directory underneath Debian, lists Etch, which happens to be one of their code names for a release. It's about to become their new stable release. And that has a release file, which has the checksums of the indexes in it. And the release GPG is the signature on that. You have the public key, you verify that that's correct, and then you go down, there are sections. So the release file references multiple sections and architectures. Main, all the different binary architectures, each one of those has a packages.gz file in it. And the sources as well. And lots of different versions of these. Then Debian also says, well, Etch is still in testing, it's not released. So they have a symlink from testing to Etch. This is what their normal distribution architecture looks like. And the pool just has a hash of the section again, and then a directory for each source package with all the binaries that that source package builds and all the versions that have been built for it. That's what a normal Debian repository looks like. With Debmarshal, we throw in some extra stuff. We use exactly the same pool structure, so I won't repeat that part. But instead of using just a distribution code name, we use a distribution and a track, so we use a subdirectory as well. It's the Etch distribution, but there's lots of different releases of that as we add packages, fix things, get it ready for release, or in maintenance, put security fixes into it. So there's a subdirectory version 23, which would be the 23rd snapshot. And a symlink to that that's automatically maintained latest that's just pointing back to 23. So your testing machines can be running Etch/latest, and they will continually get the latest thing that's been updated. You can then have multiple other symlinks pointing to versions that you have tested, that you trust more, that you're ready to stage out to more people, and they put in their sources.list file which one they want. So down at the bottom line is the sources.list that you would typically see for a client that's being updated from a Debmarshal repository. Instead of just saying Etch, it's Etch/latest. Other than that, it's pretty similar to your normal Debian sources.list file. And here's what that would look like in a tree diagram. You see the Etch, the 23 version number, and then underneath that, exactly the same layout of release, main, binary architecture, sources, and symlinks that are parallel underneath Etch rather than at the Etch layer. So it's adding one extra word into your sources.list, and now you have version control and version management on all of your architectures. So I'll get into how some of the programs are used. They're not user-friendly. I think you could describe it as user-hostile. They were written very quickly to do the job because we had a job to do, and they're to be run from scripts and cron jobs. So I want to apologize for the user interface on these. One of the things that we ran into is an actual full-size repository is very large, and you don't want to, every time you generate any minor change, to have to go through and open up every single file again, uncompress it, find all the metadata, load it all into your program, and then try to do something with it. With DAC and other repository management systems, they've gone with a full-on SQL database to store this. We found that it wasn't actually that useful to do. All we needed to do was store these things without having to reparse them. So we put them in a Berkeley DB file and we accessed it from Python just using dictionary lookups. And it turns out to be fast enough. We can process what we need to do in a few seconds on an upload. We can do the consistency checks I was talking about in about 5 minutes, and it's all CPU bound, it's not disk bound. Whereas reloading an entire distribution takes 2.5 hours. On to what some of these programs do. There's index pool, which is the basic thing that gets you started before you've begun using it. You take a distribution that you already have, you run index pool, and it goes and opens up every deb and every source package and every changes file and loads it all into the database all at once. This is the step that takes 2.5 hours to get started. Populates everything. You then run it again if you're using something like debmir or rsync to pull down your local repository from Debian or Ubuntu. Run it again afterwards. It goes through and notices the files that it hasn't noticed before, loads them into the database. You still don't have a list of which packages you want in which release, but you have the packages themselves indexed, and you don't have to open those files ever again. Make release is what does most of the work in Debmarshal. This is how you generate a new release after every upload. So in this particular invocation, we use it to take an upstream release file in an upstream distribution. We say, there's been a new sync from upstream, we've had a new mirror pulse. Let's generate a new snapshot that represents that new change. Pass it in the dist and the code name. It digs into the repository, finds all the packages, files, and generates a new local image of that, and output and re-outputs those packages inside the subdirectory, and it reassigns them. You can name the track the same as the upstream, which would be a fairly rational thing to do, or you can give it your own name. Either one works. We've rolled out one for Debian that uses the Debian code names, and then internally for Ubuntu, we've done some that use our own names. The latest symlink always points to whatever the last snapshot uploaded is, so it's much easier to locate that and just leave your test machines always pointing at it. The other thing is that this particular, when you're tracking an upstream, Debmarshal has two different modes that it can be used in. One of those modes is tracking, where it just says everything that came from upstream, I want to make that a snapshot. There's also a managed mode where that isn't the case. We want to apply all sorts of logic. We want to control version numbers and do consistency checks. But tracking mode is the simple one. It just follows along with what upstream has done. Enter incoming is the third program here. It's doing the opposite of what the make release is doing. It's just taking some packages that you've just uploaded right now, and it's adding those to the distribution. So it's what you do when you're not tracking, when you are managing your own package pool. It checks the signatures on the incoming pool, which make release isn't doing. Make release trusts that if you pulled down the whole archive, you made sure you pulled down the right thing. Debmirror does that for you. With enter incoming, it's the thing doing the signature checks. If everything checks out, move those files out of the incoming directory straight into the package pool and index everything, stick it in there. You can run it every minute. It finishes in just a few seconds, and every minute you can just keep running this over and over again. With enter incoming running on an incoming pool, you can use standard Debian pools like tools like dbuild, debsign, and dupload, which Debian uses internally. Ubuntu uses, and that way you don't have to relearn anything. You can use what the upstream are using in order to upload packages. The make release, when you're managing it under enter incoming, you still haven't generated a new distribution every time. So what you do is you run make release right after enter incoming and say, I want the thing that was just uploaded to now be a new snapshot. You can also control what gets uploaded. So when you're in development, you might want to not control anything. Anything new uploaded goes into your development track. Whereas your maintenance tracks, where you've got machines running these, they're in production, you don't want anything that just gets uploaded immediately in those tracks. So you have a release specification file. We're going to change the name on that. We're not really Red Hat people. It used to have the name .spec, and that's going to go away because that was pretty unfortunate. But make release generates a new snapshot according to, there's a number of flags on here. This particular one says to generate a new release with exactly what's newest. You can also put this release specification file that controls, I don't want this package name at all, or I want this particular version of this package name. And then you can freeze a release and have more control over what goes into it. And you typically run this immediately after running enter incoming. Here's another one. One utility that's rather handy is to simply know what the difference is between two different releases. So you can send out a message every time a new upload happens, what was actually uploaded and added into the distribution. So this particular one just computes the diff between whatever the release track is, version 89 and version 88. You can build these right into your cron job that's running every minute and send out a message whenever something changes. Yeah, it throws out the old one. Debian distribution can only have one package of a particular name. So if you want to have multiple versions of the same package installed at the same time, you actually have to give them different package names. So you'll get things like NSCD 235 and NSCD 232 to have two different versions of that package. The question was, can you do packages automatically get bumped out when they become obsolete? And the answer is they do. So the handle alias command is a very, very light layer on top of link. It's just maintaining symbolic links, but it's storing the history of what was going on when you changed them. So you could avoid this, but we put it in there anyway because we like to be able to look back and see what version any particular symlink is pointing to. The update command is what changes it, and the log command is what lets you see what's going on in that log. Now this is something that took the second half of the summer. That was how we got started, was to handle releases. The next thing we wanted to do was find out whether releases were good, if there were actually problems with them. So Chuan Kai did a lot of work trying to figure out whether or not two different packages had all of their dependencies met. And the dependencies in Debian can be fairly complicated. You can depend on something that's provided by several other packages. You can conflict with something that's provided by other multiple packages. You can have version dependencies and version conflicts. And it took a while to get all of that working to the best of our knowledge. He would write it, and then we would find that there were hundreds of flaws in the upstream distributions. And we'd look at them and find out that some of them weren't really flaws. But there was something we hadn't even considered as possible that was allowing it to work. But going through, we went through, and there's still hundreds of flaws left. There are packages that, looking at what Debmarshal spits out, they can't be installed, or at least they can't work. They might work if you upgrade from an older distribution, but if you just install the current one, you're never going to get that particular package working. There's another problem that also regularly happens with distributions and isn't well detected, is that you can have two perfectly good deb packages that provide a set of files or a set of features. And each one of them by themselves is perfectly fine, but they're both providing the same file, and neither one of them knows about the other one. Well, you can't have both of them on the system at the same time. The depackage system won't allow the second one to be installed. It will start, and then it will complain. And once it complains, apt-get, which is Debian's main package management overlord, doesn't really know what to do when depackage complains, and so the whole thing falls over and you stop getting updates. So it's very important not to have a distribution that has these problems in it. With Debian and Ubuntu, the way they do that is they have a long development cycle, and they simply they get bug reports from all of the million testers and find out that, yes, there are conflicts, and somebody reports it, and then we go fix it. With Debmarshal, we can detect those, and it can be detected in about 5 minutes on the upload. So every new package that gets uploaded, we can run this verification command and find out whether or not it's going to conflict in a way that isn't declared with any other packages that are already in the distribution. Yeah?
So on this topic, do you see that as an issue? Because this doesn't sound like a very satisfying solution to that problem. So I'm maybe around thinking the same thing. Clearly, if two packages need to be simultaneously installed and they both refer to some common file, it needs to be in different states. That's a logical inconsistency, so I don't expect that to work. But what you often run into is something where maybe the stock package from Debian installs maybe a file in Etsy, and then my service wants to change one of those files. And that's still the same problem that you're talking about, right? Because both packages will sort of own the same file, and you're saying that the package management only permits one owner per file.
Right.
So it seems like it would still be nice, though, if there was some way to permit packages that say depended on another package to, I don't know, take ownership of individual files and still have, say, file level consistency checking.
Yes, well, okay. The question was, if I'll paraphrase this, whether or not there is a way to allow multiple packages to provide the same file. And there are ways to do this. You can have two packages can provide the same file, and they are perfectly legal to do that as long as they declare a conflict with each other. Only one of them is allowed to be installed on any particular machine. The distribution can have both packages, but any one machine can only have one of those two packages installed. So that's the simplest solution, is to just have one of those packages conflict with the other, and then the package management system knows otherwise. Well, that's the simplest one. Now, the more complicated thing to do is to have the second package, rather than conflict with the first package, it diverts that particular file. This is a feature that, as far as I know, only exists in Debian, which is that you can run a command, dpackage divert, and tell it, I want you to take that file, rename it to something else, get it out of the way, and then I'll control it from now on. Whenever the original package tries to refer to the file by what it thinks the name is, it gets automatically at a lower level renamed. And the original packages, install scripts and post-inst and manage scripts, are all hitting the diverted file, which is not the live one. So only one of them has the name. They don't both have two different files at the same file name, because Unix file systems don't allow that. But they can both be installed at once, and only one of them has the file. So you might have your default configuration files that ship with the package, and then you wanted to ship another package that replaces some of those files. Well, you divert the ones you're replacing, send them off somewhere else. The first package doesn't know, and you just provide your files there. There are some complexities involved in that. As it turns out, not all Debian systems obey the diversions. Debconf, for instance, doesn't, because it's all custom scripts, and none of them bother to check whether there's a diversion. They just write directly to a file. So one of the things that you can also do with one of these derivative distributions, you can say, a tiny distribution where you might have a dozen packages is not going to have all of its dependencies met within that. It has a base distribution that all of this came from. So we specify what the underlying distribution is, and you can have multiple layers of these. So for instance, Debian security depends on an actual Debian base. And your local repository depends on at least your Debian base and probably your security packages as well. And then it goes through and it will automatically load in, when it's doing these dependencies checks, into its local repository all of the metadata to find out what conflicts without having to go and reload them continually. And that's what the underlying line in the repository's configuration file is about. Yeah?
Is there any tracking of changes in dependencies as packages get upgraded?
Well, it's storing are there any changes in are the changes stored in the, as dependencies change for packages? They are stored. Every package version that's uploaded, all of the metadata for that package is stored. So every time a new version is uploaded, a whole new set of metadata is stored for that. And it does grow, but because these are nice, compact binary hashes of just the things we needed, it turns out to be about 1/10 the size of the original packages files. Because we just aren't storing everything, we're only storing the things that are of interest to us. Yeah?
I guess I'm still trying to figure out motivation. I thought that if you wanted to create a system with a snapshot of a particular set of required versions, that the normal Debian way to do that would be to create a virtual package that has dependency links on specific version numbers for all the packages whose version you wanted to lock, even if that's everything in the system. Is there some, I guess I'm trying to understand how this is different and better than just doing it that way.
The question was, couldn't you just create a single virtual package that depended on exact versions of everything that you wanted in a particular snapshot? If you did that, what you'd end up with was your only choice to be on that particular managed release stream would be to have every single one of those packages installed.
But isn't that the definition of a snapshot, that you want a consistent known state?
Yeah, well, isn't that what a snapshot is? Well, a snapshot is what's available. It's not necessarily what you've installed. So each snapshot has 15 to 18,000 packages in it. Most systems have a few thousand packages installed.
Okay, so when you say snapshot, you're talking about a version snapshot of an entire distribution.
Right.
Not a snapshot of what is actually installed.
Yeah, it's a snapshot of the entire distribution. That's what each one of these snapshots are.
Okay.
Yeah.
How does that play out with space efficiency? One package changes between snapshot 23 and snapshot 24. How much disk space are we spending on the system?
How much disk space gets spent every time a new snapshot is generated? Well, it's generating about the same amount that every new packages file generates. So if it's a small local archive, then you're talking about tens of kilobytes. If it's the full distribution, if Debian pushes from release 1 up to release 2, then you get a full set of packages files, which are a few megabytes in size. So you can plot out that it's growing, and with modern disk sizes, you can go a couple of years before you exhaust. If you left double the space you need on your disk storage, then you can probably go a couple of years before that becomes significant. And what all of this verification gets you is basically unit testing on your snapshots. You can build a snapshot, you can stage it out to a few people, stage it out to more, see if it all works, and it's one way to test the snapshot itself. You produce it, and now you can start testing it. So the typical workflow that we would imagine using this with would be software developers produce a package, and they upload it into the pool as soon as they like their package. They've installed it on their desktop, they like it, they sign it, they upload it, it goes into the pool. Now the distribution maintainers don't have to choose this package. One of them might, whoever's doing the distribution of everything latest and new. But all the others might decide, they want to wait a little while. So you can have multiple distribution maintainers all digging out of the same pool. And some of them can be very rigorous about what gets in. If you have servers doing something very important, you probably don't want them updating just about ever. That's what our experience has been with service owners, is once they have stuff working, they don't want us messing with it at all. So you just put these different symlinks. Well, the symlinks are very lightweight. You can have as many of those as you like. Too many of them is probably too much work, but the system allows you to have as many as you think you need. And then you change the labels, find out what the difference is between them, alert people that you're making this change, and it automatically gets updated by the systems if they're running cron apt every night. You take away the -d flag, and it automatically installs the packages each night out of the distribution. It's probably safe to track the ones that are going through rigorous controls before they get updated. So there are some related pieces of software that I thought I would mention. Snapshot.debian.net, which is run by another Googler, has full snapshots of all Debian releases ever, and it's several terabytes in size. There's no local upload capability. You don't do local distributions. But it does do verbatim indices, which is something that Debmarshal doesn't do just yet. So when we generate a packages list and a release file, we re-sign it with our key rather than the Debian archive key, which has some consequences, but it gives us more control, and it was easier to do. RepRepRow is a nice little repository control system that we've used a bit. It's designed strictly for doing a local repository. It doesn't do the multi-track releases like we were talking about here. And it's very aggressive about cleaning up the pool. Every time you're no longer using a package, it gets deleted right now. We'd rather not delete them, but it is a good piece of software. It also uses a Berkeley DB to keep track of the packages and metadata. DAC is what both Debian and Ubuntu use. It does not do a local derivative repository particularly well, and it doesn't do integrity checking to any great degree. It requires an SQL database, but it is the thing that scales up to the size of the two big distributions that are running Debian packages. It's also pretty lightly documented. The Ubuntu archive maintainer and the Debian archive maintainer are both James Troop, and he knows how to make it work because he wrote it. And depackage scan packages, which is the original. It just goes into a directory, scans for all the debs, extracts their metadata, and writes a packages file. And that's all it does. It doesn't scale very well to multiple tracks. but it's something that you can use for a very lightweight piece of repository maintenance. So we have some things we want to do further with Debmarshal. We'd like to publish some good user interface wrappers around the scripts. The scripts themselves do the work we want them to do, and they're completely scriptable. But nobody really wants to look at those command lines I had in my titles there. And publish some better docs on using it and setting it up. We're working on it. This talk is part of that process. We'd also like to publish a manual of the suggested workflow when we have more experience running Debmarshal. We've already revised what we do a few times with this, changed around from using different tracks to using multiple labels in the same track and switching back and forth. So part of it is just getting operational experience and then saying what we want to do with it. Publish the integrity checks of the upstream distributions. We think most of the problems we're seeing right now are pretty much real problems. So when we're a little more confident, we'll start telling Debian people about these problems, publishing lists, and letting them and us work on it. The release files, which we're re-signing with our own signature, it would be handier if when they haven't changed, when it's exactly the same as what upstream gave us, to keep their signature. So that's just a little tweak to the program. If nothing has changed, go ahead and use theirs, because then the installers, which have the public keys hard-coded into them, can use the archive that Debmarshal is maintaining. Yeah?
Sorry, have you considered the integrity checks, isolating and separating them and sending them to Debian as a recommended integration for the actual package producing software? In other words, rather than publishing the results of the integrity checks, if you could take the automated test and build it into packaging systems, then these would cease to be a problem in the future.
Yeah. Could we isolate out the integrity checks and put it into the Debian build and process and everything? It would be somewhat difficult to do. The place we'd have to build it in would be something like DAC, because it has to be something that can see the entire archive. Most Debian maintainers have what they need to build their package, but they don't actually have the entire archive sitting on their disk. Today, it's a reasonable thing to do. The whole archive is still only a few hundred gigabytes. But it's not something that most developers have sitting on their disk that they could scan in. And it takes a couple of hours to build that index the first time. So the place to build it in would be DAC. And we haven't really worked too much with making that happen because DAC looks hard. Yes?
If the goal is to find file conflicts, why can't linting checks be run against something like the database that app file uses? Instead of getting the entire, view into the entire archive, why not just look at the list of file names involved?
Why couldn't Lintian use the existing database to just grab the list of files for each package and detect whether or not there are conflicts? Well, we can detect a lot of conflicts, but we get a lot of false positives that way too, because the list of what conflicts and what replaces and what overrides and is allowed to replace is fairly complex to calculate. So we did it this way. There are probably other ways to have done it, but I don't know that information is all out there. And parsing it locally, we were able to get everything we needed to determine whether or not there was a conflict. And the availability. Debmarshal is, you can check internally for the internal operational documentation on how we're using Debmarshal. And it's also published out on code.google.com/p/Debmarshal under the GPL version 2. So thanks for your time. If you have any more questions, let me know. Yes?
I think this is probably a more generic Debian question rather than Debmarshal, but I'm wondering about recompilation of things, like the extreme cases when you get in changes to libc, for example, and it may include some changes to header files, to a header file or two for libc. What's the normal what's the usual practice as far as finding other packages that depend on libc and recompiling them when a libc is uploaded, when there's not any specific version dependencies?
What's the Debian policy on rebuilding packages that depend on a library that's been updated? The policy is basically not to do that. Libraries that are uploaded should not break backwards compatibility if they have the same name. If they're going to break backwards compatibility, Debian policy is that they should have a new SO name and a new package name. Yeah.
So is there a way to watch for packages? Maybe the example is the easiest thing. So you've got some package and it was built with Kerberos support. And how do you know that some future version was not built incorrectly and left out the Kerberos support? Does that make sense?
Yeah. How do you ensure that some future version of a package doesn't drop some important compile flag that you needed? Well, if it's a released distribution, so if Debian or Ubuntu have released it, they should only be doing security updates. And if they determine that Kerberos is insecure and they drop that whole flag, well, I guess they can make that argument. But in general, Debian doesn't go and drop flags. They make the minimal change necessary once it's released. If it's in development, all bets are off.
And if upstream drops it, it's not Debian's fault.
Yeah.
So I want to follow up on the question that he asked because I didn't like your answer. You said that if I want to patch header file in libc that forces binary changes to most of the system, say, because everything links to libc, the answer is I can't, that I have to publish libc2 or something like that and have my package that links to libc2, and then those guys can coexist nicely. But all the previous stuff that maybe also wants to take that bug fix in, maybe I fixed a bug in malloc, there must be some way that Debian has it if I actually do, say, propagate the version of a basic library, and I do need to recompile everything. Is there some easy way to recompile everything from source? Like, I don't know, like Gentoo. In Gentoo, you can just go and change one line in some dependent header and type emerge world, and it'll go and rebuild everything.
Is there something like Gentoo where you can force a rebuild for everything if a library has a fix that was in a header file? So it really does need to be recompiled. And Debian doesn't really have that capability. It was basically the thinking is that you should be able to come up with a way not to have to do that. You should be able to make it backwards compatible without having to recompile. If the bug is in libc, you should be able to fix libc without recompiling the applications. The applications are using an API, and if the bug is not in the API, if the bug is in the malloc code itself, then fix the malloc code, don't change the ABI. If the bug is in the ABI, Debian still has gets. I think Gentoo probably still has gets too.
What do you mean by get?
Get string. So it's the get a string into a buffer and you don't tell it how long the buffer is. And so if your input line is longer than whatever you guessed the buffer would be, then it overwrites and you have a buffer overrun. That API is published. It's part of the C standard library, and Debian hasn't gotten rid of it. It's still there because it was a busted API, but it's kept for backwards compatibility.
Sure. I mean, again, I'm not trying to
Yeah.
make policies. I'm just trying to. Suppose I had that need. I needed to edit a library and rebuild my system. It doesn't support that as a functionality.
I think you'd replace the library without it.
Right, if it's a shared object.
Then you replace the shared object.
Here's a concrete example. When you did the NPTL change, it changed some of the structures, and there was some issues with the library where we compiled the older version, and now the structure size had changed, especially when you had a 64-bit system. So now all kinds of existing libraries burn on this changed version of the running program.
But if you change a published API, you've got to make the next iteration a different version of it, because that's what a published API is. Once the API is published, the whole world is depending on it. You can't just go and change it.
This is a thread API, so it's kind of harder to change that. So it's, for example, the look structures with contingent variables. I think that was the one that changed.
You're hard to hear.
Sorry. pthread interface, very public spec, so hard to change. And there were some issues with the way the user filled in structures that were passed into the functions compiled with regards to 64-bit. So then the structure size shifted from one version of the library to the next.
Yeah, but if the flaw is in the API, then you make a new version of the API. If the flaw is in the implementation, you replace the implementation. You don't have to change the API.
It was the implementation in this case.
Well, then you change the implementation. You don't have to recompile it.
Well, in this case, the implementation change didn't require header function.
Yeah, I mean,
Well,
C programs are sensitive to implementation, not just API,
Well, it depends on the API. That's a different discussion.
Yeah,
not just public API.
yeah, basically there are examples of cases where it would be nice to recompile everything because, even though the API, you want to, keep it the same, there were changes in places that do slip into the compile of your client through the include files where you might want to do that. And Debian doesn't have the capability to do that. They went with, you must come up with a way to do it without changing the API, or just bite the bullet and change the API. Go from libc version 5 to libc version 6 and make it a new package name. No more questions? Well, that was quick. Okay, well, thanks for your time. And I'll be around later.